Hello students, in today's lab we will look at the oscillations of a simple pendulum and use the oscillations of a simple pendulum to get a value of g, the acceleration due to gravity or the acceleration of free fall. So what is a simple pendulum? A simple pendulum is simply a mass at the end of a thread. So I have this little sphere of steel which is tied to the end of this massless string. Of course, the string does have some mass, but compared to the mass of the sphere, the string can be completely considered massless. Now, what we are going to do is we're going to displace this sphere to a side, and when we release it, it's going to start oscillating. Now, as it is moving back and forth, what we say is that one back and forth motion is called one oscillation. So when it starts at the center and goes to one side and goes to the other side and comes back to the center point again, that motion is what we call one oscillation. So starting from here, go to the extreme, go to the other extreme, come back, and that's one oscillation. The time that the pendulum takes for one oscillation is what we call the period. So what we will do is we will measure the time for 20 oscillations, not the time for one oscillation, because in measurements we know that the bigger a measurement is, the more accurate it is, the less percent uncertainty we will have. So instead of measuring the time for one oscillation, we will measure the time for 20 oscillations. Then we're going to repeat that because there will be random uncertainties, and then take the average, and that gives us the average time for 20 oscillations. And dividing that time for 20 oscillations by 20 will give us the period, which is the time for one oscillation. So the pendulum at this point is already set to be 1 meter long. So I already set this pendulum. This is exactly 1 meter long. And because the instrument that I'm using, the meter rule, has a least count of 1 millimeter, therefore when you write the length of this pendulum, it should be written as 1.000 meter, because the least count of the instrument you're using is 1 millimeter, which is 0.001 of a meter. So we're starting with length of the pendulum is equal to 1.000 meter. So we have our pendulum here. We're gonna displace the pendulum and we're gonna let it oscillate a few times, and as it is oscillating, then I'm gonna come in and start my stopwatch, and when I start the stopwatch, I'm gonna start counting from 0 and stop it when I hit 20. So here we go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we got a time of 40.73 seconds for the first oscillations. Okay, so the length is still 1 meter. I'm gonna displace the pendulum once again. I want to measure the second time. So this is time for 20 oscillations, second time, and then I'm going to take the average. So here we go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the second time I got is 40.32 seconds. So let's fill in our report now. So we have first length is 1.00 meters. Then we have the first time for 20 oscillations was 40.73, and then we have 40.32. We want to find the average of these two. So 40.73 plus 40.32, and then divide that by 2. So we get 40.525, but because we want to write it to only 2 decimal places, so this would be 40.53 seconds. And then we take 40.53 seconds and divide that by 20, and that gives me 2.03 seconds. So that's the time of one oscillation. So on my report, I go to the next page and I want to fill this out in my table. So the table starts with length is equal to 1.000 meter. The time for 20 oscillations was 40.73 seconds. Then it was 40.32 seconds. Then the average was 40.53 seconds. And then the period was 2.03. And then I need also to find the square of the time. So I'm going to say 2.03 squared. And the calculator says 4.12. So this is the first row of my table completely set up. Now it says here that I want to change the value of L so that L is between 1.000 meter and 0.400 meters, and I need to have 6 set of readings. So I'm going to reset the length of my pendulum to 90 centimeter, and then I'm going to find the time for 20 oscillations again, and then repeat that, find the average, and then get the time for one oscillation, and then square it. So now since I took the time, I measured the time for you last time. So what I'm going to do is I'm going to let the pendulum oscillate, and I will let you measure the time for 20 oscillations. So I'll count it for you. So be ready when I say 0. That's the time for you to start the stopwatch. And then once I say 20, that's the time for you to stop the stopwatch. So we're going to measure the time twice. So I have changed the length of the pendulum now. You can see that the length of the pendulum now is 90 centimeter. And I will now displace the pendulum, and I will count the oscillations for you. So make sure that you have a stopwatch and you're ready to measure the time. So here we go. Length is 90 centimeter, and this is first set of 20 oscillations. Ready? 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so hopefully you have the time for 20 oscillations. I am going to displace it again, and we're going to measure the time for 20 oscillations. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Now I'm just going to let it swing without counting so that you can measure the time again if you messed it up. So be ready. Now what you can do also is remember there's this vertical rod of the pendulum. You can also use that as a reference point. So whenever the string comes in front of it, you can count your oscillation. So I'm going to just let it swing, and you can do the counting and you can measure the time as well. Okay, so I let it swing about 30 times. Hopefully you measured the time for 20 oscillations. So now what we're going to do is we're going to reset the length to 70 centimeters. So we're going to reset the length to 80 centimeters. So we started with 100 centimeters, 90 centimeters, and now we're going to change it to 80 centimeters. All right, so the pendulum is now set at the length of 80 centimeters. Okay, you can see that the pendulum is 80 centimeters. I will displace it. I will let it oscillate for 30 times, so you can get the time for 20 oscillations easily. So you can start your stopwatch whenever you are comfortable, and then count 20 oscillations, and then stop when you hit 20 oscillations. So I will let it oscillate for 30 oscillations. Okay, so that was 30 oscillations, and I will let it oscillate once more for 30 oscillations so that you can measure the time for 20 oscillations again. So here we go. Okay, so that was 30 oscillations. Next, I'm going to change the length of the pendulum to 70 centimeter. All right, so the length of the pendulum now is 70 centimeter. You can see that. And I will let it oscillate 30 times, and then you can measure the time for 20 oscillations. And then I'll let it oscillate for another 30 times. So here we go. Okay, so hopefully you got your first time for 20 oscillations. I'm going to let it oscillate for another 30 times. Okay, so hopefully you did get your second time for 20 oscillations. So next what I'm going to do is change the length again to 60 centimeters. Okay, so the pendulum now is 60 centimeters long. The other way around. So the pendulum is now 60 centimeters long. I will let it oscillate for 30 times. You can measure the time for 20 oscillations easily. Hopefully you got the measurement. I'm going to let it oscillate another 30 times so that you can get your second reading. Okay, now after this, the last set of readings, I'm going to change the length of the pendulum to 50 centimeters. So now we have our pendulum, which is set to a length of 50 centimeters. So this is the last set of readings we're going to take. So I'm going to let it oscillate for 30 times, and then you can measure the time for 20 oscillations. Okay, so hopefully you got the time for 20 oscillations. Let's repeat this. So now you have your table all filled in. You have values for L, you have values for t squared. Your report says that you need to plot a graph of t squared on the y-axis against L on the x-axis, and then use the graph to do the rest of the lab report. So hopefully you enjoyed doing this lab.